We will now discuss the case of a projectile at an angle. Now, in the previous lesson, in the previous part of this lesson, we talked about a projectile that is projected with a horizontal velocity, the case of a horizontal projectile. The more general case of a projectile motion occurs when the projectile is fired at an angle theta with the horizontal. Now that is very common around us. Now watch this illustration here. A golfer is hitting a ball, and look at this. The golfer hits the ball with a velocity v0. v0 is the velocity that is imparted to the ball the moment it is hit. And now that v0 is at an angle theta with the horizontal. And what happens? The ball rises to a height, at the same time moves horizontally. You can see it has an x motion and a y motion. Alright. If v0 is the velocity vector of the golf ball, can you tell me what are the components of this vector along the x-axis and along the y-axis? What is the component of v0? The angle it makes with the x-axis is theta. You know from our discussion on vectors, if a vector v makes an angle theta with the positive x-axis, its x component will be v times cos theta and its y component will be v times sine theta. So the x component of the velocity will be v0 times cosine of the angle theta, and the y component will be v0 times sine of the angle theta. You see, the horizontal motion is due to the horizontal component of velocity. The v0 cos theta is responsible for the horizontal motion, and v0 sine theta is responsible for the vertical motion. Alright, let's spend a couple of minutes talking about these velocities. Tell me, the component of v0 along the horizontal, along the x-axis, is v0 cos theta. Tell me, what happens to that velocity with time? Because there is no force in the x direction, the x component of the velocity will not change. v0 cos theta will remain a constant. Now look at the different positions of the golf ball. The horizontal velocity will not change. The horizontal velocity will remain a constant. But what happens to the vertical velocity, v0 sine theta? The vertical velocity will decrease, will become smaller and smaller until at the highest point the vertical velocity is 0. And then on, the vertical velocity increases in the negative direction. Right? Okay, so these two concepts are very important for us. Now, the time taken by the projectile to return to the ground is called the time of flight. So the golf ball is hit from this point, it rises to a maximum height and then falls back to the ground here. The time taken to do that is called the time of flight. And the horizontal distance traveled during that time of flight is called the range of the projectile. So range of the projectile is this horizontal distance it traveled during that time of flight. So some of these terms are very important for us. Now, when Tiger Woods hits a par 5, Well, the first ball, he wants to take it as far away as possible. The range has to be a maximum, as much as possible. Is that right? We will talk about that as we move on. Now, let us consider the case of a ball that is projected at an angle theta with the horizontal with a velocity v0. Alright, there is the velocity v0 at an angle theta. Now, v0 has a component vx0. What does vx0 stands for? Vx is the x velocity. Vx0 is the initial x velocity. So, this v0 has a component vx0 equal to v0 cos theta along the x-axis. This is v0 cos theta. And vy0, what does vy0 stands for? Initial vertical velocity. vy0 is v0 sine theta. I'm sure you have no problem understanding that. Now, vx0 remains a constant. This velocity will not change because there is no force in the x direction. Therefore, you cannot have an acceleration. The x velocity v0 cos theta remains a constant. vy0 decreases, reaches 0 at the highest point of its path, and then increases in the negative direction because of the gravitational force on it. Is that right? Okay. Now, this is the example again that we have talked about. The velocity of projection is v0. The component of that velocity in the horizontal direction is v0 cos theta, where theta is the angle of projection. And the component, the vertical component of that velocity is v0 sine theta. At any given time, the ball has a horizontal displacement and a vertical displacement. You see, because it has a horizontal velocity, it will move horizontally, and because it has a vertical velocity, it will move vertically. That means the ball has a horizontal displacement and a vertical displacement simultaneously. That means if you now look at the ball, say here, what is the horizontal displacement of the ball now? The horizontal displacement is this distance. What is that equal to? Because the horizontal velocity does not change, vx0 is a constant. So that horizontal displacement will be x equal to vx0 multiplied by time t, and vx0 is v0 cos theta. So x equal to v0 cos theta times t. That will be the x position. Now this x position is vx0 multiplied by time. And this is the y position. Now how will we obtain the y position? What is the equation for the y position? Y equal to vy0t minus 1/2 gt squared. Now here we assume that the ball was hit from the origin so that y0 equal to 0. Is that right? So y position is vy0 minus 1/2 gt squared, because its acceleration is always directed downwards. What is the value of vy0? vy0 is v0 sine theta. So the y position is v0 sine theta t minus 1/2 gt squared. And this is that y position. That means at any given time, the projected ball has an x displacement given by x equal to vx0 times t, which is v0 cos theta times t, and a y displacement given by y equal to v0 sine theta t minus 1/2 gt squared. Now look at this animation of a projectile at an angle. A ball projected with a velocity v0 at an angle theta with the horizontal from a height y0. This time the ball is not projected from the origin. The ball is projected from a height y0. Alright? So let's have a look at this. This is our y0. So can you now write the y position? What will be the y position? The y position now will be y of t equal to y0 plus vy0t minus 1/2 gt squared, and that will be y of t equal to y0 plus v/0 is v0 sine theta t minus 1/2 gt squared, and this will be the position function because the projection is now done from an initial height y0. Okay, now watch what happens. I want you to watch the animation. What happens to the horizontal velocity? The horizontal velocity does not change. Look at the arrow there. It remains a constant. And look at the vertical velocity. The vertical velocity decreases to 0 and then increases in the negative direction. Alright? And you can actually follow with time how the y velocity changes. The x velocity does not change, but the y velocity will keep on changing.